right. So I'm going to be talking about what's ARM doing for the Silicon Root of Trust and what are our efforts to be aligned with OCP security objectives. What we want to do is make sure we have a way for architectural enhancements in the ARM ecosystem while integrating the security objectives that OCP is putting forward. So my name is Sridhar Valluru. I'm the Director of Product Management at ARM. Among other things, I look after security for Neo solutions. So I work with all the ecosystem partners and our customers to ensure the architectural framework is deployed in the right way, right? So today, what I'm going to go through is to give you a flavor for what do we do in our IP development process. This is to make sure that you understand our process is aligned with what OCP primarily looks forward to in these aspects as to how do you make sure these are secure, open, and other kind of things. And then go through the additional security things that we do to make sure the IP that is geared towards security deployments are covered and make sure the platforms are secure. And then introduce our Silicon Root of Trust as to what we are doing and how are we approaching that problem. Our development process is a cyclical process. Any IP that we develop today starts with a framework of how a very clearly defined hardware and software specifications. These specifications are defined in conjunction with our architectural development, but we also look at, get feedback from our ecosystem partners to understand what are the things that we are trying to solve from a particular product, right? This is not necessarily a security product, but any product that we're developing. We have a very rigorous process for translating those specs into a design, similar to any other company that does hardware design today. Fairly robust regression and validation process. And this is crucial for ARM, which is different from any other silicon vendor, is we feed into multiple customers. So we have to look at a wide, varied range of deployment scenarios to understand what are the corner cases that we need to hit, right? So that basically gets us to have a very extensive verification environment and validation environment that covers a range of scenarios, and we take partner feedback to make sure we are covering the deployment scenarios that they're worried about. But our process, that ends the IP development process, but that we also have a fairly robust IP deployment model. This is where we handhold our customers on how to get the IP, what are the things that they need to get from ARM from a system solutions perspective. We develop app notes. How does it meet from a system reference perspective? How does it have to comply? What do they have to do to comply with system integration aspects and so forth, right? And ARM does not provide all the IP, so we look at how do we integrate third-party IP into the systems. What does it mean? What are the processes that they have to follow to integrate any IP to make a solution support? And once the IP goes into the field, we also have a fairly robust support system, so that way people have somebody to pick up a phone and talk to understand what does it mean if they have issues in integration, field deployment, anywhere during the life cycle of their product. So when we overlay security aspects on top of this, we have three different aspects that we have to cover. First is we have a process called secure development lifecycle process. This covers every stage of the development, all the way from architecture spec definition to development and verification, to understand what threat models are they addressing, how are these things addressed in the IP from a various deployment scenario perspectives. So that covers the development of the spec, implementation of the IP, verification of the IP, and each IP, irrespective of whether it's security or not, has an SDL report that any partner who licenses ARM IP can get to. That SDL report includes the threats that have been addressed and the threats that have not been addressed in our environment. So the customer who's integrating that IP can look at what does that mean from their deployment scenarios. Does it meet the needs or what they have to do to beef up those things? We also have a very robust security response team. They basically look at any vulnerability that is announced. We replicate those and analyze the threats, and then find a suitable response that we communicate to the ecosystem. It's a fairly robust process that has been deployed and has worked fairly well. In this process, we engage with the experts in the ecosystem. We engage with our partners, industry experts, university researchers, and so forth, to make sure we cover the exploits that are disclosed. And once we analyze, we have a robust response, we go back to the partners and the end customers to explain how do they respond to these threats. We also have third-party certification capabilities, so we certify the products where they're needed, but we also have the ability to work with our partners and the ecosystem to provide our IP for analysis, for auditing, and any kind of threat analysis perspectives that they have to do, right? So we can reach out to any of the researchers that OCP wants us to work with to analyze our IP for different kind of threats. So that brings us to the ARM Silicon Root of Trust. So what are we? We have a new Silicon Root of Trust that we're developing. So it's a standalone root of trust that does the lifecycle management for the SOC. It isolates all the security assets from the rest of the SOC. The foundation for this root of trust has been approved to be, or certified rather, to be a root of trust for a SIM card, as well as an integrated root of trust for a SOC. The IP is protected, has been developed to mitigate software attacks, physical isolation. It has a fairly well-defined physical isolation, so it has a fairly small TCB in the system. It's protected against physical attacks using the software RTL mechanisms and software countermeasures. We do have parity and ECCs in the RAMs where needed for making sure they're protected. And the system is built using DCLS-based mechanisms at the CPU level. So that helps you identify if there are any physical attacks being introduced in the system by identifying the differences in the bus framework. Primarily, the root of trust is an enclave for ARM CCA, which was introduced earlier. So this is an implementation of ARM HES for the confidential compute architecture. It captures the boot measurements from the entire system, the TCB that the ARM CCA defines for its implementation. It supports attestation for the ARM CCA, is ARM PSA compliant, and implements TCG's DPE framework. And the entire firmware for RSC is open sourced, and it's aligned with what OCP is expecting from any IP that needs to go into the security system. So what our goals for RSC are basically, we build a silicon root of trust that is a standardized framework that provides a standardized framework, not just at a hardware level, but the entire framework, the flows point of view, for ARM architecture as well as OCP security needs. We are implementing DPE, so it allows the attestation frameworks for confidential compute architecture. So one of the reasons we are approaching OCP is, as you have seen in the earlier talks, security is fairly rapidly evolving in the OCP infrastructure because our customers have a problem that needs to be solved. But we are also enhancing our architecture to make sure we are addressing the security concerns overall as a solution, not just at the platform level, but as an architecture point of view. So we want to make sure we're providing a framework for integrating all the enhancements that we are doing, as well as what's coming down the pipe from the OCP, and provide a reference for the ARM ecosystem that meets these overall solution objectives while minimizing the TCP and reducing the attack surface. It has the capability to be deployed in any kind of scenarios, not just application processes, but we have partners who build devices around ARM architecture. So our call is basically we are looking at, okay, how do we work with OCP to enhance our solutions overall to make sure it meets the OCP security needs. So the burden is on ARM to begin with to see how do we work with OCP to enhance, but we are also looking at our ecosystem partners to work with us and OCP to make sure the solutions are fairly robust. Right? We have a few links that I've included here where that we are complying with, and that's my talk.
Sri, can you double-click cover provisioning and deployment of scenarios?
Yes. So if you look at the a root of trust, it has a need for programming the root of trust with its own keys and other stuff, right? Different partners have a different way of programming the keys into the system. How do we make sure that's compliant with the flows that you are looking for? And how does it comply with each of the deployment scenarios?
Okay, so I believe we have a talk about this later in the agenda, right?
Sure.
It's a good manufacturing talk.
Yep.
Hi, is RSC only deployable in ARM SoCs, or could it be deployed in other kinds of SoCs?
So I guess you've implemented RSC HIS in a NVIDIA way of implementing. So RSC is built on ARM's M35 CPU. So it has a trust zone-based system. So it's a standard framework. You can look at it as two different things. One is hardware. How is the hardware built? And what's the firmware stack doing, right? We provide a reference firmware that not just ARM partners, if other people can make use of that framework, they're more than welcome to take it and use it.
Got it. So it is more a generic root of trust IP.
It's a generic.
It doesn't depend on ARM architecture.
It doesn't depend on. It's been built for ARM architecture, but it's robust enough that others can pick up and then use it as well.
Thank you.
Thank you. And by the way, when I say it's robust enough, that's my view. You all can audit it and then tell us that too. So.
All right, thank you.
Thank you.
Much.